Okay, this is Jill Nichols. We are going to start this class in Chapter 1, Section 1. Chapter 1 is all about lines, linear things. The first section is just about solving linear equations. Now, this is something that you've probably done before. For example, I would assume probably all of you, at least in high school at some point, solved equations that looked something like this, right? So you would, to solve it, subtract 5, divide by 3, and you have x. X is typically a variable. That means some quantity that you don't know. Like maybe you know that 3 times x plus 5 is equal to 0, but you don't know what x is, and that's what you're trying to figure out. So that's what a linear equation looks like that you've probably seen before. We're actually going to do a little bit more advanced examples because this is college and you're going to be going into the real world after college. So these are more applied problems. It means there's a lot more decimals and numbers that are a little bit more realistic and fractions and things. That's what we're going to start out with to hopefully help get you more comfortable with those types of numbers. But the process of solving linear equations, which you've certainly done before, even if you have forgotten, is still the same. Okay, so the point of algebra, well, basic algebra, is to solve for unknown quantities. Something that you want to know, and you have to do a little math to get to the answer, right? So algebra is just a language that you can use to help you write down all your information that you have in an organized fashion in order to solve for the variables or the unknown things that you want to find. Okay, so we're going to start with an example. Basically, we're just going to work lots of examples, and I'll teach through the examples. Okay, so we're going to start with an application right here. Some of these are in your textbook and some are not, but this does follow along pretty closely with your textbook. So I do recommend that you read the section in your textbook. It sounds silly, but they're fairly short. It won't take you but just a couple minutes, and it really might help explain some of this stuff even better. So maybe read it before you watch the lecture or after you watch the lecture, this video, whichever makes more sense for you. Okay, so in this first example, you plan to purchase custom printed lunch coolers for your school staff. If you order 50 or more lunch coolers, there will be a $45 setup fee, and each lunch cooler will cost $3. Okay, first we're going to break this down into multiple parts. See, here's A, B, C. This is all about cost equations here. Trying to figure out how much something would cost. Next, we're going to move into revenue, that is how much money selling a product brings in, and then we'll move into computing profit, or how much you make when you create and sell items. Okay, but we're going to start here with just basic cost. If you want to sell something, so imagine you're like a business owner sort of for these problems, and you're trying to sell something. Cost is what it costs you to make your product. Okay, so right here, let's see, we're trying to get this product, okay? You plan to purchase custom printed lunch coolers for your school staff. If you order 50 or more lunch coolers, there will be a $45 setup fee, and each lunch cooler will cost $3. Well, let's go ahead and assume that we are going to purchase 50 or more, okay? So the total cost then would be, well, there's $45 to start with. Okay, so cost is equal to the $45 plus $3 for each lunch cooler. If we let L, capital L, represent the number of lunch coolers, then the cost of the total lunch coolers is L times 3 because they're $3 each. So L times 3, or normally you write the number first. That's called the coefficient. 3 is the coefficient of the variable L. So that's an equation that represents cost in terms of the number of lunch coolers provided. So let's use this right here. How much would 75 lunch coolers cost? In fact, let's reduce this space here. How much would 75 lunch coolers cost? Well, we have an equation right here. We're going to use that equation to figure out how much 75 lunch coolers would cost. So the total cost for 75 lunch coolers, well, if we plug in 75 for L right here, plugging in 75 for L, Parentheses, by the way, mean multiplication when you put parentheses around two things. So this means 3 times 75. If you can't do that in your head, that's completely okay. That's a good use of a calculator right there. I'm going to pull my calculator up. I'm not sure if y'all can see this in the recording. I'll have to check that out later. But I'm going to do 3 times 75. 3 times 75 is 225. So we'll have 45 plus 225. And then when you add those together, 225 plus 45, 5 plus 5 is 10, so I have a 0, carry the 1, my carried 1, plus this 4 is 5, plus 2 more is 7, and 2. So 200, let's put a unit there, $270. So it costs $270 in order to purchase 75 lunch coolers. Now there's a point I need to make here, and that is the order of operations. You've probably heard that phrase before. Order of operations. There's an acronym that can help you remember what order to go in when you have something like this and you're not sure how to enter it into your calculator. And it is parentheses, exponents, multiplication, division, and addition, subtraction. The numeric device, or not, that's not, mnemonic device that helps you remember it is, please excuse my dear Aunt Sally. Okay, and the idea is you first do apply any parentheses. Well, we have parentheses there, but really this is multiplication. Then any exponents, well, no exponents here. Then the important part for this problem is the fact that multiplication and division come before addition and subtraction. So the wrong way to do this one would be to do 45 plus 3 first, and go, okay, 45 plus 3 is 48, and then do 48 times 75, which is some huge number, and definitely not the cost of making or of buying 75 lunch coolers. Okay, next question. How many lunch coolers can you purchase with a budget of $400? Okay, so you have $400 to spend, let's say, and you're buying lunch boxes. You want to know how many you can buy. Well, they're $3 each, but there's also this $45 setup fee, right? So, I don't know, it's definitely going to be more than 75 lunch coolers, because 75 lunch coolers would cost $270, right? But what we can do is we can take this equation that relates the cost to the number of lunch boxes, and we are asking how many lunch coolers. That means what is, right here, that means what is L. How many lunch coolers, we can translate that to mean what is capital L when if a budget of $400, that means your cost that you can spend, C, is $400. So let's plug in $400 for this C right there. Okay, so we'll have 400 equals 45 plus 3L. And that is a linear equation. Okay, yay, you've probably seen these before. We are trying to figure out L, that is the number of lunch coolers. So we want to solve this equation. Now, once you get it written as an equation, I mean, really, you don't have to think about it in terms of lunch coolers and setup fees and all this stuff. You just follow the mathematical rules, which generally say that you can do anything to an equation as long as you do it to both sides. So in order to get L by itself on one side, we have to somehow move over the 45 and the 3. So the 45 we're going to move over by subtracting 45 from both sides. Okay, and that gives us, let's see, 400 minus 45 is going to be 355. And 45 minus 45, those cancel. So we have 355 equals 3 times L. So then to get rid of the 3, we need to divide both sides by 3. Divide by 3, divide by 3. Now those 3's do cancel. We're going to talk a lot more about when you can cancel and when you can't, but the 3's cancel in this case because 3 divided by 3 is just 1. And we get L equals, let's be very clear with your work. I'm at a space at the bottom, so I'm going to do an arrow over here. L equals, let's see, 355 divided by 3, but I need to get a whole number, like how many whole lunch coolers can it cost? So let's do that on the calculator. 355 divided by 3 is, let's see, my calculator says 118.33333333. My pen's not working. There we go. 118.3. If it says 333333 forever, a way to write that is just to put a little bar above that 3. That means 3 repeating. Okay, so we can purchase 118 and 1/3 of a lunchbox. Well, we're not going to purchase 1/3 of a lunchbox. We're either going to purchase 118 or 119. If you think about it logically in this problem, it makes sense to round down. Not because 3 is less than 5, but just because you can't, well, if you purchase 19, you're not going to be within budget. So let's actually plug that in so you can see what I'm talking about. If we plug in, let's use different color here. If we plug in 19 for L, just to see what happens, we'll get 45 plus 3 times 19. It should be just a little bit above $400. Let's see, 3 times 19 is 57, no, 119. I don't know why I'm saying 19. 119 is what I meant to say. Okay, is 3 times 119 is 357, plus 45 is $402. So that would not be in budget of $400. So we're going to have to round down and order 118 lunch boxes or lunch coolers. So that's a case where you would round down. Even if this had been 118.9, we would still round down because if you rounded up, then you wouldn't be within budget anymore. Okay, so that's a pretty straightforward applied application problem with solving linear equations. Okay, now I went ahead and put another one in here, not necessarily because I think you need to see it, because a lot of you probably don't, but just, you know, in case it helps you, basically. So, and I think it will, as we have a little time because I'm doing this on the internet. So what you should do at this point is pause this video and read this question, and this one is, I believe, in your book, by the way, too, and try to answer this one completely on your own. Okay, and then when you're ready, or you want to see, or you get stuck, restart the video and watch how I solve it. Okay. So the question is, while you are on spring break in Fort Lauderdale, Florida, the cost C in dollars of your taxi ride from the airport to your hotel can be represented by this equation. C equals 2.10 plus 2.40 m when the ride is m miles long. Okay, so in this example, you're actually given an equation, which is nice. Now we need to look more closely at what does these variables mean and what does this problem say. I mean, just so you know, when I read a problem, I usually have to read it at least 3 times before I really start to understand what the variables are and what's going on. So reread the problem as many times as you have to. I mean, your teacher reads it about 3 times before it makes sense to her, so you might have to reread it 3 or 5 times, or if you're really with it, maybe just once is good. Anyways, what is C again? Let's see. C is the cost in dollars of your taxi ride from the airport to the hotel. It doesn't really matter where you're going in this problem, so it's the cost in dollars. Okay, so let's make a note of that. C equals the cost. You don't have to always write out your variables, but it can be really helpful to do so. Let's see. What is M? It says when the ride is m miles long. So M is the number of miles that your taxi ride is. Okay. So what will an 8-mile taxi ride cost? So if it's an 8-mile ride, that means M is equal to 8. So we can plug in M equals 8 right there into that equation and solve for C. Actually, it's already solved for C. We just have to plug in 8 and then do a computation. So 210, that must be like what they charge you when you get in the taxi there. $2.10 or something. So plus another $2.40 for every mile. So times 8 miles. Okay, so we'll do 2.4 times 8 to compute this. So on my calculator. That is 19.2. 2.4 times 8 is 19.2. So we have 210 plus 19.2. Let's see, the 0.10 and the 0.2, I mean, this has two decimals, this doesn't. You can write a 0 there if it makes you happier. Right? So 0.10 plus 0.20 is 0.30. And 19 plus 2 is 21. If it's a straightforward calculation, I do recommend, guys, that you try to do them without a calculator because it's good for your brain. I mean, it really is. Making you think is good. It helps you grow, helps you learn. So try to do little things like that without a calculator, okay? But if you need it, that's fine. So, okay, so it looks like if you go 8 miles, it's an expensive taxi ride. Cost you $21.30. Okay, next question. How many miles can you ride if your budget, oh, typo there, if you budget $35 for the taxi ride? That's right. How many miles can you ride if you budget $35 for the taxi ride? Okay, so that means your cost is $35, right? C is $35. So, and we're trying to find how many miles. That means what is M? If it helps you to write things like this, like what I'm writing, write it out. If it doesn't help you, that's fine. Don't write it out. Okay, so let's plug in 35 for C and to see what we get. So we have 2.10 plus, I'm looking at this equation up here, plus 240 times M. M is the unknown here. That's the variable that we have to solve this equation for. Now the only difference between this equation and the previous one is that this one has some decimals, but you solve it the same way. Don't let the decimals scare you. Okay, so we're going to start by subtracting 2.10 from each side. You always have to subtract first before the division because, well, we're sort of going in the opposite order of PEMDAS, right? But let me just do it the wrong way. So what I'm about to do is wrong. If you were to divide by 240, those actually don't cancel because the numerator's not factored. We'll get into the details of why that works that way later. But for now, okay, we just subtract 210 from both sides. If it helps you to write like this, then write it. If it bothers you, don't write it. Okay, 35 minus 2.10. You know, if you can do that without a calculator, good. If you need it, use it. Is 32.9. So we have 32.9 on the left. Those cancel. Equals 2.40 M. Okay. Now we can divide both sides by, I'm just going to recopy it up here. Now we can divide both sides by 2.4. The O there really doesn't even matter. So 2.4 divided by 2.4. So we get M equals, now I'm flipping it, right? I'm putting the M over here on the left side just because it's typical to at the end put the variable on the left. 32.9 divided by 2.4. Now I cannot do that in my head, that's for sure. So 32.9 divided by 2.4 is, what's a long decimal? 13.70833. And it keeps going, but let's do 13.70833. Now that's not my answer. And actually, let me show you something. I cut off lots of decimals. It looks like the 3's go on forever. You could either put a little bar there to indicate that the 3's repeat. Technically, let's add a little more space here. You would need to put an approximation sign. You need to put M is approximately 13.7083. If I don't put the little bar there, because M equals this number, that's exactly M, but if you round at some point, then you're approximating M. So that's the approximation symbol there. All right, so that's the variable, but it's not the answer to the question. The question is, how many miles can you ride if you budget $35 for the taxi ride? Well, you can go, it looks like 13.7 miles. You know, it doesn't actually specify how many whole miles. You could answer, you can go 13 whole miles.
I would probably answer you can go, let's see there, you can go about 13.7 miles, because that seems like a good place to cut it off right there. Nobody really thinks of miles more precisely than 1/10 decimal place anyway, so. All right, so those are two examples of revolving around cost, okay? But there's more to it. Like, again, say you're a businessman and you're going to sell something. You not only do you have to consider the cost that it makes to produce and sell your product, you have to look at, how much money do you make when people buy your product, whatever it is. How much money do you make? And then figure out, hopefully you make more money than you spend producing it, right? And that gives you your profit. Okay, so revenue. What is revenue? Revenue is, it's the amount of money that you're bringing in through sales. Sales is one way to put it. It's the amount of money brought in through sales. So for example, and this is in your book too, say you're selling pizza, because this is it's a pretty simple, good example. If you're a pizza place, right? And if you sell, let's say 10 pizzas, and your price is $12 each, well then you're bringing in $120. So your revenue is $120. You just multiply the 10 pizzas times their cost of each pizza. Okay, but then you have to say, well, how much did it cost me to make those 10 pizzas? You're the owner of the pizza place, okay? So cost is it's your expenses. It's the expenses of making the product. There's two types of costs typically that you would break it down into or think about. There's fixed costs, and you can read in more detail about this in your book. Fixed cost, it's cost that you have just for basically opening your door before you even produce any of your product. So you have to pay your fixed cost no matter what. It's things like the cost it took to build your building that you're working in, to pay your employees, to pay for the utilities. You just open the door and you have a lot of fixed costs, right? So let's see, that would include things such as rent, utilities, probably some salaries too. The other type of cost is called variable costs, and those are ones that depend on the number of items that you produce. So that's the part that depends on like how many pizzas you sell, essentially. So variable cost depends on how many items you produce. So your variable cost might be, in a pizza world, for example, say maybe it cost you, I don't know, $3 to produce each pizza or something. That's really cheap. But if it only cost you $3 to produce each pizza, that would be your variable cost. Okay. Profit, that's the difference, right? Hopefully your revenue, the money that you bring in, is more than the cost, the money that you pay out, and you have a little left over, right? That's why people start businesses and things. They're trying or hoping to make a profit. So your profit is the revenue with the money that you bring in minus your cost. That's minus your cost. So for example, let's just say straight up that maybe if the cost of producing those 10 pizzas that we were talking about earlier is $100. We're just making that up. But say it cost you $100 to make 10 pizzas. Basically, it cost you $10 per pizza. So how much profit do you have in the end? Well, that's your total cost is $100. Your total revenue is $120. So we're going to subtract, let's abbreviate here, rev minus cost. Revenue minus cost is 120 minus 100, or 20 bucks. Sounds like a lot of work to go to me to make 20 bucks, but that's the idea. That's the conceptual idea behind revenue, cost, and profit. Break-even point, that's it's how many of your items do you need to produce and sell in order to at least cover your basic costs so that you don't lose money. It's basically when your profit is zero. So it's the point at which the cost equals the revenue. So you're spending the same amount of money that you're bringing in. You don't really want to be at that break-even point ever, right, as a business person, but you want to know where that break-even point is. Another way to think about it is it's where your profit actually equals zero. Okay, because if your cost is higher than your revenue, then you're losing money. You're below the break-even point. And if your revenue is higher than your cost, then you're making money. So the break-even point is that middle amount there. Okay, so let's look at an example. This one is broken down into, let's see, A, B, C, D, E, F, G, H. Lots of parts. So we're going to go all through the whole cost, revenue, and profit parts here. So Golf Carts to Go sells refurbished golf carts in South Florida. The company has fixed cost of $26,000 per month. That's a lot. For rent, salary, and utilities. They can buy used carts and refurbish them for an average of $1,400 each. They sell the carts for an average price of $2,500 each. Golf Carts to Go can refurbish only 55 carts a month. Okay, now what you need to do is pause this video and reread that a number of times until you understand the problem. Okay, so we're going to first write an equation for the monthly cost of refurbishing N carts. All right, let's see. So Golf Carts to Go sells refurbished golf carts. I'm trying to just read through the important parts. The South Florida doesn't matter. Let's see. The company has fixed costs of $26,000 per month. That's their fixed cost. Let's see. I'm going to color code this a little bit. What they're for doesn't matter. They can buy used carts and refurbish them for an average of $1,400 each. So that's important. Refurbish them for $1,400 each, roughly. They sell the carts for an average price of $2,500 each. So they buy a cart for $1,400, they refurbish it, and then they sell it for $2,500. So right there they're making $900 on each cart. But that's not really true because they have fixed cost of $26,000 a month for the building, salary, utilities, and all that stuff. So you have to count that too. There's a lot of information going on here, right? It's too much to do in your head. And I think that's one thing a lot of students come in trying to do is trying to do all these problems in their head by doing little scribbles here and little scribbles there. The point of algebra is really to relieve you from having to do work in your head because you write it out in a mathematical sentence in a way that allows you to do the logic of the problem, what's algebraically, right, by solving equations and plugging in variables and whatnot. Makes it easier to do. I can't really do this one in my head. There's just too much information here. So we're going to start by writing an equation for the monthly cost of refurbishing N carts. Okay, cost. We're writing a cost equation, so let's call it C for cost. So cost means cost to me or you. You are the business owner. What does it cost you just to refurbish N carts per month? Okay, so there's two types of cost. Remember, fixed and variable. Your total cost, let me write this out here because I didn't write it up ahead. Total cost is the sum of your fixed costs and your variable costs. So we want to take both of those into consideration here. And we want to find total cost, which I'm going to call capital C. My fixed costs are, we're looking at per month. It says monthly cost. This is all in per month. So $26,000 is my fixed cost per month. My variable cost, that's what it costs per golf cart. So they can buy and refurbish them for $1,400 each. So if I have N carts, N could be 10, it could be 1, whatever N is, and it costs $1,400 for each of those N carts, then the product of buying and the price of buying and refurbishing N carts is the product, 1,400 times N. Okay, so that is the equation. Now you should get in the habit of boxing your answers. I don't think I did that on the previous ones. I did a little bit, okay, because they're pretty straightforward, but do get in the habit of boxing your answers. Okay, how much does it cost then to refurbish 20 carts? So which variable is 20? Is that C or is that N? Okay, N is the number of carts. You might even want to write that. Number of carts equals N. Okay, so that means N is 20. And we're asking, how much does it cost to refurbish 20 carts? Let's just assume that means in 1 month. So it'd be plugging in N equals 20 right here. 26,000 plus 1,400 times 20. And this is where you would get out your calculator. 1,400 times 20 is 28,000 plus another 26,000 is 54,000. Wow. $54,000. So that's the cost, let's box that, of refurbishing 20 carts in a month. Okay. Write an equation for the monthly revenue from selling N golf carts. That's actually a little bit easier because the carts sell for $2,500 each on average. So if they sell for $2,500 each and we sell N of them, say, let's use R for revenue. Revenue is total amount that people pay us, right? So that's $2,500 for each cart, or 2,500 times N. There's my revenue equation. Okay. Next, how much revenue will the company make if they sell 10 carts? So we're just plugging in 10 right here, right? They'll make $2,500, and it's important that you show all this so that I understand that you know what you're doing. So let's do, actually you don't need a calculator for that, right? Because 2,500 times 10, that just means you add a 0 on here. So that would be $25,000. Now notice the fixed cost of running the place for a month is $54,000. Well, if you only sell 20 carts, that's not good because you're only bringing in $25,000. You haven't even covered your cost. You just lost a lot of money. Okay, so just wanted to point that out. Next, let's write an equation for the monthly profit the company makes if they refurbish and sell N carts. Okay, remember profit is the amount of money you bring in, revenue, minus the cost. Let's write that out. In fact, write it every time until you have it memorized. Profit is the revenue minus the cost. So P for profit, we're putting this in terms of N. So it's this revenue equation right here, 2,500 N minus the cost function up here. Here it is, 26,000 plus 1,400 N. So 26,000 plus 1,410. You do have to put a parenthesis there. 26,000 plus 1,400 N. So that is my cost here. Oops. Or revenue, the money we bring in, minus the cost, the money that we pay out. in terms of the number of carts. Okay, so let's just plug in a number and see where we're at. We know if we only sell 20, we have not hit the break-even point because we haven't sold enough carts to cover the cost. The cost of producing 20 carts is $54,000. The revenue from selling, oh no, that was 10. Oh, I'm comparing apples and oranges. I hope y'all noticed that sooner. This one I plugged in 20. For this one I plugged in 10. So you can't even compare those numbers. It doesn't even make sense. So forget what I was saying there. Okay, so what is the profit from refurbishing and selling 25 golf carts? We're going to plug in 25 for N. So let's see what we get. 2,500 N. And actually, let me back up. Before I do this, so I just noticed, I can simplify this equation, my profit equation, and that'll make it easier to do computations. You may or may not remember have seen this, so let's just go ahead and review it. We needed these parentheses here because there's a plus sign. Whatever is out front, whatever's being multiplied by everything in the parentheses gets distributed. Okay, so the minus sign gets multiplied, or you can think of this as minus 1, times everything on the inside of the parentheses. So this is really 2,500 N minus 26,000 minus 1,400 N. So 2,500 N minus 1,400 N. Let's see, what is 2,500 minus 1,400 is 1,100 N. You just subtract those coefficients. So I'm combining these two terms right here, including the signs. 2,500 minus 1,400 is 1,100 N. And then we still have this minus 26,000, which doesn't combine with anything else because this term and this term both have N's. Okay, so it's a 6. All right, there's my simplified profit expression. Let's use that one. So what is the profit of refurbishing and selling 25 golf carts? So we're going to plug in 25 for N. So P is 1,100, right? Plugging in right here. 1,100 times 25 minus 26,000. So let's see. 1,100 on my calculator times 25 is 27,500 minus 26,000 is $1,500. 1,500. So you make a profit of $1,500 if you make and sell, or refurbish and sell, 25 golf carts in a month. Okay, so that's not a very big profit, I don't think. But at least they broke even, right? So how many golf carts does the company have to refurbish and sell to earn $20,000 in profit? Well, so we're asking, what is N? How many golf carts does the company have to refurbish and sell? That can be rephrased as, what is N when, let's see, profit is 20,000. So when P equals 20,000. So let's take this profit equation down here and plug in 20,000 for profit, and let's just see how many golf carts it would take. That's a good question. How many golf carts would it take? So it's 1,100 N minus 26,000. Okay, so now we need to solve this linear equation. The numbers are kind of big, but that's okay. So we're going to need to move this negative 26,000 over to the other side, over here to the left, in order to get the 1,100 N by itself. So I'm going to start by adding 26,000 to both sides. By the way, if you don't like to write this step that I'm doing, please don't. And in fact, I actually hate writing this step that I'm writing right now. I'm doing it because I think some of you probably need to see it, but I'm going to try to drop doing that pretty soon. Okay, so 20,000 plus 26,000 is 46,000 equals 1,100 N. So to get N by itself, I need to divide by 1,100. So 46,000 divided by 1,100 is what I'm doing. 46,000 divided by 1100 is 41.818181818181. Okay, so 41.81 repeating. So, here's the question. Do we need to make 41 golf carts or 42 golf carts if we want to make a $20,000 profit? 41 or 42? Let's see. Let's think about it. If you make 41 golf carts, you're going to be bringing in less money. So that's probably not going to be quite enough to hit 20,000. And if you're not sure, let's just plug it in to check. Let's plug in 41 into the profit equation up here. I think it's going to give us slightly under $20,000. So P equals 1100 times 41 minus 26,000. Let's see what that is. 1100 times 41 minus 26,000 is, $19,100. Okay, hopefully you could figure that out by just thinking about it, realizing that 41 isn't going to quite get you there. So you're actually going to need to make 42 golf carts, or make and sell 42 golf carts in that month in order to have a profit. Your profit will actually be a little bit bigger than 20,000 because this is not a whole number. But that'll get you at least a $20,000 profit. Okay, next and last part of this question is, how many golf carts do you need to refurbish and sell in order to earn a $40,000 profit? That's huge. Okay, this is very similar, basically the same as this part G. So pause the video and try this one on your own. I am going to plug in 40,000 into the profit equation. You know what? I need to copy my profit equation because I can't see it. So P is 1100N minus 26,000. Let's read that first. 1100N minus 26,000. So my profit is 11. Oops, nope. Let's just copy that. I'm plugging in 40,000 for profit. So 40,000, that's P right here, equals 1100N minus 26,000. You already saw me do the details there, so I'm going to skip this little orange step there that I hate. Let's just add the 26,000 to both sides. 40,000 plus 26,000. Well, that's 40 plus 26 is 66,000 equals 1100N. So 66,000 divided by 1100 is exactly 60. It's a lot of golf carts. So if you can produce and sell 60 golf carts, you will make $40,000 profit. And that brings us to this next example, which is in your book, so you can just read this one in your book if you'd like. I definitely recommend that you pause this video here, try this one on your own, and then restart it in order to see if you did it right or not, okay? So a local chiropractor has a small office where she cares for patients. She has $8,000 in fixed costs each month that cover her rent, basic salaries, equipment, and utilities. For each patient that she sees, she has an average additional cost of about $15. The chiropractor charges her patients or their insurance company $80 for a visit. So write an equation for the monthly cost when patient visits are done in a month. Now, remember this, you're the business owner, okay? You're the chiropractor, so this means cost to you, the business owner. Okay, so what is the monthly cost to you if patient visits are done in a month? Let's see. So, remember there's two kinds of cost, fixed and variable. And let's scroll back up here. This is an important equation. I should probably put some stars, highlight it, circle it, whatever. Total cost equal your fixed cost plus your variable cost, okay? So we'll figure out both of those and add them together. Okay, so total cost is fixed cost, which is 8,000. let's see, plus variable cost. Okay, she has an average additional cost of $15 for each patient she sees. So it only costs her $15 per patient, or 15V, because we have V patients. And I recommend you do, I don't know, maybe cursive, or just make it really clear that it's a V in a letter and not some number or something. Okay, so that's the cost function. I should probably have just called it C. I'll just put C over here. Okay, let's shorten the space here. Let's see. What is the total monthly cost then if the chiropractor has 100 patient visits during the month? And the computer is hanging on here. So if the total, let's see, if you have 100 patient visits, that means your V right here, V, is equal to 100. So if we plug in, call it C, if we plug in 100 patient visits, that means V is 100. So if I plug in right here 100 for V, we'll have 8,000 plus 15 times 100. And this is an all-important step because it shows me that you understand what you're doing. It takes you about a second to write, so do please write that step. If you just start writing numbers everywhere, you're going to get 0, okay? Don't just take numbers for answers. You have to show your work, or it is not worth anything. Okay, so 8,000 plus 1,500 is 9,500. So the total cost to you to see 100 patients is $9,500. Let's go box all our answers here. Okay, so what is then the equation for the monthly revenue when V patients visit in a month? Let's see. So your revenue, that's how much you bring in. Well, it says she's charging her patients $80 for a visit, so that's $80 times the number of visits. It's pretty straightforward on that one. Okay, so let's write an equation for the monthly profit that the chiropractor makes if she has V patients visit in a month. Okay, equation for the profit. Remember, profit is the money you bring in minus the money you spend. So profit is your revenue minus your cost. So 80V minus the cost function, 8,000 plus 15V. Now, if I write it like that, that is wrong. You have got to have parentheses right there, okay? Because you've got to remember to distribute this minus out to both terms. Let's go ahead and simplify this profit equation here. So this is 80V trying to do this. Distribute that -1 times both terms on the inside. So this becomes minus 8,000 minus 15V. 80V minus 15V is 65V, because 80 minus 15 is 65. And we have minus 8,000. What is the monthly profit when 150 patients visit in a month? Well, let's see. Hopefully it's positive, right? Let's see if we plug in 150 for V. 65 times 150 is 9,750. So minus 8,000 is 1,750. So you make a profit of $1,750 if you get 150 patients in 1 month. How many patient visits does this chiropractor need to have in a month for her profit to be $5,000? Yeah, that sounds like a little bit of a low profit to me. So if you want your profit to be 5,000, we're going to plug in 5,000 for P in the profit equation, which is right there. So plugging in 5,000 for P gives me 65V minus 8,000. We are trying to solve for that V. That's what we want. So we're going to add 8,000 to both sides. Now this is one you can do in your head. No scratch work necessary because the numbers are really easy. 5,000 plus 8,000, well, 5 plus 8 is 13. So that's 13,000 equals 65V. So divide both sides by 65. I can't do that in my head. 13,000 divided by 65 is 200 exactly. So to have a profit of 5,000, that needs to be written out more clearly. She needs to see 200 or have 200 visits, let's say. 200 patient visits. I'll go ahead and box that, but this is the answer that makes sense. Okay, so that's a lot of applied examples. That got you started, I hope, in seeing how linear equations are useful. I mean, this is pretty basic stuff, so they are more useful than what we're capable of showing you, or what I'm capable of showing you at this point. But you got to get the basics down first. So now let's just switch over to basic algebraic equations in order to practice your skills with this stuff. So we're going to start with some fractions. I know everyone probably loves fractions, but no, really they're not that scary. You just have to, get used to dealing with them. What I recommend doing is actually first getting rid of all the fractions. It makes it easier to solve. If you don't have to worry about adding fractions and subtracting fractions and getting common denominators, and you don't want to deal with that, let's just get rid of them. Because you can do anything you want to an equation as long as you do it to both whole sides. So my question is, what would we need to multiply both whole sides by in order to eliminate both of these denominators, the 4 and the 8? In other words, what's the lowest common multiple of 4 and 8? In this case, 8 is the answer. We're going to multiply both sides by 8, and you'll kind of see when we do it how I got 8. But 8 is the lowest common multiple of both 4 and 8. So if I multiply both sides by 8, you have to put it out times the entire side. Okay, you know what, let me switch to a different color. So we're going to do 8 times the whole left side, 1/4 x plus 3/8. By the way, the x is not in the denominator. It's 1/4 times x. Okay, plus 3/8 equals 2 times 8. So we're multiplying 8 on both sides. Okay, now that's because when you distribute this out over both terms, you get 8 times a fourth. I'll write it out this time. 8 times a fourth times x for your first term, and 8 times 3/8 for your second term. Right? So if it helps you, and 16 on the right, so if it helps you simplify, let's look at this one first. 8 times 3/8, the 8's cancel. If it helps you, write this 8 as 8 over 1 if you want to, and then maybe it's more clear that, okay, the 8's, you multiply numerators and you multiply denominators. So the 8's cancel, and you're left with just 3. So that fraction went away, which is good. 8 times a fourth, that means 8/4, right? If you just multiply them together, 8/4 is 2. Okay, so we have 2x plus 3 equals 16. And now it's a really simple linear equation that you can solve. Once you get it like this, you shouldn't really need to write this thing. I'm going to write it minus 3, because the numbers are so easy you can do it in your head. On the left we have 2x, and on the right we have 16 minus 3, or 13. So x is 13 divided by 2. You could write it like that. That's how I would leave it. You could also put it as a decimal if it's an exact decimal. Now this one would be an exact decimal. All right, 13 divided by 2 is 6.5 or 6.5. And don't do this. Don't write 6.5. Mixed fractions are just ugly. They're hard to work with when you get into algebra. So let's keep it as either an improper fraction or an exact decimal. Okay, so pause the video and try the next one on your own first. Again, this one has fractions, so I'm going to start by clearing the fractions by multiplying both sides by whatever number I need to, hopefully the smallest number necessary in order to eliminate both denominators. The two denominators we have are 5 and 10. Their lowest common multiple is 10. So I'm going to multiply 10 times both sides. So 10 times 2/5 times x plus 4 on the left equals 10 times 7/10 times x minus 5 on the right. Okay, Now this is being multiplied. You actually don't distribute here. You don't do 10 times 2/5 and 10 times that right there because everything's being multiplied. This just is 10 times 2/5 times x plus 4. So, it's like saying a times b times c, or 5 times 2 times 3. The order doesn't matter. So I could just write it like this if I wanted to. 10 times 2/5 times parentheses x plus 4. Now over here there's a minus sign, so we do distribute that. There you go, that 10 out right there. So you have 10 times 7/10 times x, and 10 times -5 is minus 50. So on the left, 10 times 2/5. The 10 and the 5, 10 divided by 5 is 2. So that becomes a 1, that becomes a 2. Taking a 5 out of both. Over here the 10's cancel. So on the left we have 2 times 2, which is 4, times x plus 4 equals 7x minus 50. So now we want to solve for x, okay? We have two x's in the problem. We've got one of them right here, right there, and another one right here. In order to solve for x, we need to get it by itself on one side of the equation. So we'll start by just expanding everything, which means to distribute. So let's distribute this 4 out to get 4x plus 4 times 4, 16, equals 7x minus 50. Now we're going to solve for x. So we need to put both the terms that have an x on one side. We have a 4x and a 7x, and then all the constants on the other side. I like to do it in such a way that I end up with positive numbers if necessary. The first thing I notice is that 7x is bigger than 4x. So I think it makes sense to subtract 4x from both sides. And that gives us 16 equals 3x minus 50. Now let's add the 50 over. And I just often kind of illustrate that by doing a little arrow. I'm going to move that negative 50 to the other side by adding 50 to both sides. 50 plus 16 is 66. Well, that's nice because 66 divides nicely by 3. So 66 divided by 3 is 22. So there's your solution, 22. And you can always plug it back in to check. Let me show you how to do that. And that's something that it might be easier to even do on a calculator too. We have 2/5, I'm copying this equation, but what I'm going to do is plug in 22 for x. So 2/5 times 22 plus the 4, does that equal to 7/10 times 22 minus 5? Okay, 22 plus 4 is, let's see, 26. So we have 2/5 times 26. Does that equal to this? Let's see, 7 times 22, I don't know. 7 times 22 is 154. Okay, and so we have 154 over 10. And then minus 5. So let's see, 26 times 2 is going to be 52 on the left over 5. Does that equal, let's see, 154 over 10. You know what, let's just write this as with a common denominator. Well, no, let's write it over 5 so that we can see if the left equals the right. If I divide both the numerator and denominator by 2 here, I can reduce it. 154, let's see. Try to move this over. Oh, not going to let me. 154 divided by 2 is 77. So that's 77 over 10. Over 5. 154 over 10 equals 77 over 5 minus 5. 5 is equivalent to 25 over 5. So 77 minus 25. 7 minus 2 is 5. 7 minus 5 is 2. That does work. So that's how you can check your work. Okay, so let's do another example. It's just straight up solving example. This one involves a few decimals. 6p minus 3 times 4.1p plus 2 equals 3p plus 13.2. Solving for p. Okay, so pause the video, try it on your own first, and then if you get stuck, restart to see what I'm doing. We can combine like terms. Now there's not always one order you have to go in.
In this one I can see two things you could do first. One would be to distribute this negative 3 out over these parentheses. Another thing you could do is subtract 3p from both sides in order to combine this 3p with this 6p. That's all you could do to start with. So let's see, I'm going to move the 3p over first because that to me looks easier. I like to just denote it like this. Moving the 3p over to the left. 6p minus 3p, I can do that in my head, is 3p. Okay, now let's just go ahead and distribute while I go. Let's distribute minus 3 out times both of those terms. So negative 3 times 4.1 is going to be negative 12.3p. Negative 3 times positive 2 is negative 6 equals 13.2. Okay, now you look for like terms, meaning constants, like the 13.2 is a constant, the negative 6 is a constant, so I can add the 6 over here on the right and combine those. These are also like terms because they both have a p. So 3p minus 12.3p. We have to do 3 minus 12.3. It's not letting me move my calculator to where you can see it, but anyways, 3 minus 12.3 is negative 9.3. So on the left we have negative 9.3p equals, now we're going to move this 6 over, 13.2 plus 6, 13 plus 6 is 19.2. So p is 19.2 divided by negative 9.3. Definitely need a calculator for that. 19.2 divided by 9.3 is, it's a decimal. 9, let's see, let's do an approximation sign on this one, I think. It's approximately, let's see, 2.0645. P is approximately negative 2.0645. How many decimals you got to just depends on the problem. If you wanted to keep it in exact form, here's how we could do exact form, is we could multiply this fraction by a number that would make these decimals go away. 10 over 10 would work really just fine because 19.2 times 10 is enough to get that decimal to go away, just 192. And same thing over here, 9.3 times 10 is 93. So that's the exact version. Here's the rounded version. Okay, so again, pause the video, try them on your own. Let's do this one here. So solving this one for x, you know what, actually this one and the next one are in your book. I think that's probably enough. Try those two on your own. And then start on the homework, and if you have trouble with these two I will do them in class, but I'll save those to be in-class problems if you have trouble with them. So we're going to move on to the last and final topic for today, which is about solving equations for different variables. You work through the same process. It's nothing complex, okay? It's just some equations have more than one variable. So, for example, let's look at this one. Solve the equation r equals p times q for p. Meaning you want to get this p right here by itself, okay? So to do that, you have to get rid of the q. So we would need to divide both sides by q. Let me rewrite this. R equals p q. So if we divide both sides of this equation by q, then we get p equals r over q. Okay, that's how you can solve an equation that has multiple variables for just any one of those variables. Okay, next we have h equals 1/3 m squared times r. Let's try solving that one for r. Now this one's a little bit more, there's got more to it, right? Because we have a fraction and we have an m squared. Let's handle one at a time. In order to get the 1/3 over to the other side, we would actually need to multiply both sides by 3. So I'm going to have 3 times h on the left equals 3 times 1/3 m squared r on the right. Okay, then the 3 and the 1/3 cancel. So I have 3h And actually, don't do what I just did there. Just do a simple line through it so that I can see what you did. So I have 3h equals m squared r. So to get r by itself, we just need to divide both sides by the m squared. So that gives us r equals 3h over m squared. Okay, let's do one last example here. Solve d equals ax plus c for x. So it's just like a linear equation we've been doing. It just has variables instead of all numbers. Okay, so we want to solve for x here. So I'm going to start by moving the c to the other side by subtracting c from both sides. That will give me d minus c equals a times x. And then if I divide both sides by a, I get x equals d minus c over a. Okay, so again, I'm going to save this last one to do in class. So watch this, start your homework, and then bring any questions that you have to class, and I will see you on Wednesday.